f of x equals 3x to the fourth plus 4x cubed minus 12x squared and plus 5. Perfect. Okay, so in order to start, we have to start with the domain, right? And what do we know about this function? What type of function is it? And what is its domain?
It's a polynomial.
Very good. And the domain is?
All real numbers.
Absolutely. Very good. Negative infinity to infinity. There is no, a polynomial function is smooth, continuous function, no asymptotes, no gaps, no jumps, no etc., etc. Good. So 0 has to be in the table. So when x is 0, can anyone give us the y value?
Is a 5.
Thank you very much. Indeed. Very good. Now at negative infinity and positive infinity, which of these terms is the most powerful?
3x to the fourth.
Very good. So nothing else matters for infinity and negative infinity. So at when x approaches negative infinity, where does this go?
Positive infinity.
Perfect. And at positive infinity, where does it go?
Infinity.
That's it. One thing I need, and I can move on to the first derivative. So to solve the equation f of x equals 0, in other words, the x-intercepts. X-intercepts. Also called the zeros of the function. Okay, so what is the degree of this polynomial?
4.
Very good. How many solutions? If degree is 4, how many x-intercepts do I have to find?
4.
Yes, 4. Of course, I jumped by saying x-intercepts, right? But they're basically the zeros, right? But they may be real or imaginary. I don't know, right? But when I solve this equation, I have to find the 4 solutions. They may be real, imaginary, I don't know. Okay. So 3x to the fourth plus 4x cubed minus 12x squared plus 5 equals 0. This is not factorable because it's a degree, polynomial degree 4. We have no algebraic method of factoring this. So I need to find the x-intercept somehow. And I'm looking for my other calculator, not the TA. Okay, here it is. It has a way. I failed to look over the weekend where that is.
Professor, I
Yes.
actually figured out how to do that. So you
That's
go
it.
to app,
Yes, I did. I did go to apps.
and it's number 9.
Oh, that's it. Very good. Thank you very much. Here it is. Polynomial root finder. Excellent. Thank you very much. I knew it was in, okay. So the order is the degree. Degree 4. And next. Okay. Excellent. This does the same thing. But this is an old calculator. Okay, so in order, 3, 4, negative 12, and 5. Thank you so much. So 3, 4, negative 12, 0, because there is no x, 0 for the coefficient of x, and 5 for the last one. Okay, finally, give me the solutions. Okay, so this is even a better setup than my old TI-86. Excellent. So the solutions are 4 solutions. X equals negative 2.72, x equals 1, x equals almost 1, I'm going to consider it twice, and x equals negative 0.6. Excellent. Thank you so much for discovering that. I knew it was in apps, but I just didn't remember which one of them is. Okay, perfect. So that's my last step here. I need to put these in the table. Negative 2.72, 0, 1, 0, and negative 0.6, 0. So this is an x-intercept, this is an x-intercept, this is a double x-intercept as expected with 4 solutions. So this is a double. Normally, what happens, because this was very close, right? What happens when there is a double solution, we call it multiplicity 2, second, so multiplicity 2. The function will turn there, either opening up or opening down. That should come up as a max or a min. So this should be 0 here. We'll see in a moment if that happens. Okay, so we exhausted everything about f of x. The limits, the x-intercepts, the y-intercept. That's it. Now we move on to the first derivative. So, are you with me so far, everyone? Yes? Any questions? Okay, f prime of x. Can anyone tell us the derivative of this function?
12x to the third
12x to the third plus
12x squared
minus
24x.
24x. Excellent, very good. Okay, so no critical numbers coming from f prime being undefined. Would you agree? Only from f prime of x being 0. How many solutions do I have to get?
3.
Yes. So, of course, I will have to pull out the 12x, right? And then I have x squared plus x and minus 2 set equal to 0. So, of course, 12 can be simplified. I divide both sides by 12. X could be 0. And this, can anyone give us the factored form of x squared plus x minus 2?
X plus 2 and x minus 1.
And x minus 1. So we have two options here. Then we have x equals negative 2 and x equals 1 as expected. Why? Because every time there is a multiplicity 2, even multiplicity, we will have to get a max or a min there. So I have, the function has 3 critical numbers. They have to be in the table. Okay? I'm going to reconstruct my table on the next page only because I have 0 is there, negative 2. I don't have room here between negative 2.72 and negative 0.6 and 1. So I'm just going to reconstruct you don't have to do that. You just erase if you don't have enough room. But for me, it's more difficult to erase than just write create the table again. That's real quick. So now I have negative 2.72, then I have negative 2, negative 0.6, and I have 0, and I have 1. So now at 0 is 5. At negative, so these are the infinities we determined. This is 0, this is 0, and this is 0. Now the first derivative is 0 here, is 0 at negative 2, and it's 0 at 1. At this point, I need to find the sign of the derivative, of the first derivative. Now, a comment about your work, and I do have the solution somewhere here handy. You just filled up, not all of you, but some of you, I'm just looking for the solutions. You just filled up something in there. You just put some signs. No, you cannot just put some signs. We cannot just say, oh, okay, well, I think it's negative and positive. No, you cannot do that, right? You have to test with a number. So you take a number between 0 and 6 and you plug it in and you see if you get a positive number or a negative number. Don't just fill in with the signs. Okay? So please pay attention to that. I'm not filling in signs as I please. I test, and based on that, I fill in the sign. Sorry about that. It's off. So now, here is the first, let me write again the first derivative. So the first derivative was 12x and x plus 2, x minus 1. I prefer the factored form, and I'll show you why. So if I plug in a number here, like -10, this is negative, this is negative, and this is negative. 3 negatives will give us a negative. I plug in -1 between -2 and 0. This is negative, but this is positive, and this is negative. So I get 2 negatives, so this is positive. Now this one is difficult a little bit because I have to plug in 0.5. But this is positive, this is negative, 0.5 minus 1 is negative, and this is positive. So this must be negative. And then I plug in 10, positive, 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 so this is it. So don't just fill in some symbols. You have to test. I tested with -10, I tested with -1, I tested with 0.5, and I tested with 10. Now, as you know, this is the moment of truth. This is when I catch my mistakes. Because if these two rows are not in sync, I'll say, oops, and go back to the drawing board, start from scratch. Okay, so let's see. From infinity to, oh, I have to determine this value here. I have everything else. So, plug it in, -2. I put my calculator away for no reason. So 3 multiplied by -2 to the 4th, which is 16, plus 4 multiplied by, this is -8. Put it in parentheses, please. And then a minus 12 multiplied by 4 and plus 5. So -27. I need this number here. Please correct me if I'm wrong. I'm going to just make sure I do it again. So 3 times 16, that's correct. And 4 times -8, that's correct. -12 times 4, that's correct, plus 5. I think I'm okay. Good. So now, from infinity to 0, does this function decrease? Yes, it does. From 0 to -27, does it decrease? Yes, it's correct. From 0 to -27, it does. From 27 to 0, yes. From 0 to 5, yes, it's increasing. From 5 to 0, yes, of course, it's decreasing. And from 0 to infinity, yes, it's increasing. So these two rows are in sync. When the function decreases or increases based on entries that we got, or the y values that we got, the first derivative supports that, or vice versa, if you want. So what happens here is supported by the numbers that I have here. Finally, I move on to the second derivative, but not with this, but with this. So I will differentiate and find the second derivative, which is 36x squared, and then plus 24x, and then minus 24. So now the second derivative may or may not give us points of inflection. It better give us something. So this is quadratic. How many solutions do we expect?
2.
2. Okay. So I'm going to set it equal to 0 and factor out a 4. 4, even a 6. No, a 12, right? So 12, 3x plus 2x squared minus 2. Am I correct? I think I am. Set equal to 0. So then we have 3x squared plus 2x minus 2 equals 0. And thank you for refreshing my memory where that is, number 9. So this is degree 2. And the coefficients are 3, 2, and -2. It didn't take that for some reason. I have to do it again. Okay, degree 2, yes, Yes, 3. Yes. The next one is positive 2. Enter. And the last one is negative 2. And that doesn't help me. Okay, good. And solve. So the solutions are x equals 0.55 and x equals negative 1.2. Of course, just intentionally to mess me up, right? So then I have to put in here 0.55, and this is 0, and negative 1.22, of course, just to mess me up, right? So in here, this is extremely important to put in the correct place. I have this, and I have 0. And yes, I have to determine this number. Normally, I will redo the table to make sure that everything is in the correct order and looks nice. It is in the correct order, but it doesn't look very nice because I didn't have enough room between those numbers. So now I have to enter negative 1.22 and 0.55, and I'm going to do it with the I'm going to share my screen and do this. So I'm going to enter the function, the original function, which was 3x to the 4th. And then plus 4x cubed. And then minus 12x squared. And then plus 5. And I want these two y values for x 0.55 and for x negative 1.22. Okay, so one is 2.31, 2.31, and the other one negative 13.48. Okay, that is done. And now let's study the sign here, here, and here for the second derivative. So I'm going to plug in 10. So obviously a negative 10. So this is positive. Let me also put in it so everyone can see. So now I'm entering the second derivative to study its sign. So that was 36. Very simple because I know where it's 0, but let's say we are doing it with a calculator. It's quadratic, so we don't need to do this, but that's fine. Let's do it with a calculator. Plus 24x. And I can also plug it in the one without factoring out 12. It's the same thing. I only need the sign. I don't need the number. Okay, so to the left, I'm going to plug in negative 10. And it should be positive. I plug in 0, of course it should be negative, and I plug in 10, of course it should be positive, as expected because it's quadratic. So we knew that, but that's another way of doing it. So once we have all this, we are analyzing now. So can anyone tell us what type of point is negative 2 comma negative 27? And then I'm going to ask what type of point is negative 1.22 comma negative 13.48. And of course, I'm going to ask what type of point is 0 comma 5. And what type of point is 0.55 comma 2.31. And of course, 1 comma 0. Who would like to help with this?